Hello. Today we'll discuss the comparison between the series and parallel circuits. At the same time, we will also solve one example. Example is that we have the two resistors connected in series, and voltage applied here V. The current is given 8 ampere, and this is R2 is 2 ohm, and the current flowing through this is I2. This is R1, current flowing through this I1, and here the circuit current is given. This is a circuit current, and this R1, R2, these are the branch current. This is circuit current, and this I1 and I2, these are the branch current, and this current are flowing through the branch. That's why it is called as the branch current. This is the circuit current. This is flowing through the circuits. So here we have to find mm, the current of 8 ampere. It is given, and it is shared between the two resistors. We calculate the current in 2 ohm resistors. So we have to calculate the current flowing through this current we have to calculate. Okay, and that this resistance it is given, it is a 2 ohm, and we have to calculate the current flowing through this resistance 2 ohm. So this can be calculated by using the current division method. Division means here the current is getting divided. It is I1 and I2, and as we have to find the current flowing through this I2, what we require the total current I into, we have to find the current flowing through this I2, we have to take the resistance of the opposite branch, that is the R1 by the sum of this resistance of these two branches. So this is the formula for finding I2. And now total current is 8 ampere into R1 is 2 divided by 2 plus 2, because this R1 is also 2, R2 is also 2. So this is 8 into 2 by 4, 2 to the 4 to the 8. This is a 4 ampere. So in this way we can find the current flowing through the resistor R2 by the current division method. Okay. Now let us discuss the series circuit versus the parallel circuit. Series versus the parallel circuits. For that we have to calculate, suppose 3 resistors are there. This is R1, R2, R3. R1, R2, R3. And for the parallel, we have the circuit like this. R1, R2, and R3. This is R1, R2, and R3. This is voltage source. This is also the voltage source. Okay. So here the total current is flowing here. The current flowing through this, suppose resistance R1 is suppose I1, current flowing through this R2 is suppose I2, and current flowing through this R3 is suppose I3. Here the circuit current is I, okay, and here it is a voltage across this is suppose V1, voltage across this is suppose V2, and the voltage across this is suppose V3. Total current is flowing like this. So here, what is the voltage across this? It is a V1. Voltage across this is V2. Voltage across this is V3. So the current, as far as the current is concerned, the current is same in all the parts of the circuit. So I is equal to here, I1 is equal to I2 is equal to I3. Current is same. And here, total current supplied to the network equal the sum of the currents in various branches, where current I is equal to, this is I1, this is I2, and this is I3. So total current here is equal to the sum of the current in the various branches. So as there are three branches are there, so total current is equal to I1 plus I2 plus I3, where the total current is same. I1 is equal to I2 is equal to I3. Now come about the voltage. Now what is the voltage here? Voltage is different here. So the total voltage of this circuit is equal to addition of these three voltages, V1 plus V2 plus V3. Whereas in this case, the total voltage across the parallel circuit, it is a combination or is the same as the voltage across the branch. So what is the voltage? V is equal to, it is V1 is equal to V2 is equal to V3. So here the voltage is same, okay, and here the total voltage is the voltage across each resistance. Here the voltage across this resistance is same to the supply voltage. So this is about the current, this is about the voltage, and the third is about the resistors. Third is about the resistors are in series circuits R1 plus R2 plus R3, and in the parallel circuit equivalent resistance can be found like this. So the reciprocal of the equivalent resistance equal the sum of the reciprocal of the branch resistance. So in this way, this will help you to understand the series and parallel circuits. And in series circuits, again, I will convey that in series circuit, if you add the given resistor in series, then remember always that the total resistance is always greater than the greatest resistance. Greater than the greatest resistance. Resistance in the circuit. So this will be helpful for a check when combining series registers. Suppose uh, three registers are there. Suppose this is 2 ohm, this is 3 ohm, and this is a 5 ohm. And when we have to connect this in series, then the total resistance is always greater than the greatest resistance. What is the greatest resistance in this, among these three resistors? It is 5 ohm. So obviously the total resistance answer is coming greater than this greatest resistance. It is 5. So if you add, it is a 5 plus 3 plus 2, it is a 10 ohm. So obviously the 10 is the, and 10 ohm is the answer. But if your answer is coming suppose less than 5, then definitely it is not right. So this is just for checking the whether your answer is correct or not. The total resistance is always greater than the greatest resistance in the circuit. And similarly, the for parallel circuit, parallel circuit, the total resistance is always less than the smallest resistance in the circuits. Smallest resistance in the circuits. So again, this will help you a check to check whether your answer is correct or not. Suppose again this is a 2 ohm, 3 ohm, and 5 ohm. And when you connect these resistances in parallel, then the total resistance, that is answer, is always less than the smallest resistance in the circuit. So if you connect these three resistance in parallel, your equivalent resistance, it is less than this 2 ohm. When it is less than 2 ohm, then it means your answer is correct. Means this is just for the checking purpose. So in this way, series and parallel circuits. Thank you very much for watching this video.